FastMCP 3 implements a token-based authorization system that enables tools to access and utilize authentication context through dependency injection. The framework's getAccessToken utility function provides a standardized mechanism for retrieving the current OAuth token within tool implementations. We will examine how this artifact initializes a FastMCP server instance and demonstrates token access patterns through two tool implementations that leverage the getAccessToken dependency to customize behavior based on authentication state and token claims. From FastMCP, import FastMCP. From FastMCP server dependencies, import getAccessToken. MCP equals FastMCP token access server. At MCP, tool. Def personalized greeting, SDR. Greet the user based on their token claims. Token equals getAccessToken. If token is none, return hello guest. Name equals token, claims get name, user. Return hello name. At MCP, tool. Def user dashboard dict. Return user-specific data based on token. Token equals getAccessToken. If token is none, return error, not authenticated. Return. Cliented, token cliented. Scopes, token scopes. Claims, token claims. This code demonstrates how FastMCP tools can access authentication token data using the getAccessToken utility function. The pattern shows two tools that retrieve the current token to make user-specific decisions, handling both authenticated and unauthenticated scenarios gracefully. The personalized greeting tool fetches the token and extracts the user's name from claims, falling back to guest or user when appropriate. Similarly, User Dashboard returns token metadata including client ID, scopes, and claims, or an error message for unauthenticated requests. This approach enables tools to implement custom logic based on user identity and permissions beyond simple authorization checks. The design choice to make getAccessToken available in tools provides flexibility for implementing user-specific behavior without requiring separate authorization middleware. However, this places the burden of token handling and null checks on each tool implementation. The pattern works well for simple use cases, but could become repetitive in larger applications with many token-dependent tools. Let's break it down. From FastMCP, import FastMCP. Imports the FastMCP class from the FastMCP module, which provides the core functionality for implementing the Model Context Protocol MCP in this application. From FastMCP server dependencies, import getAccessToken. Imports the getAccessToken function from the FastMCP server dependencies module, which provides access to the current authentication token for tools to make user-specific decisions. MCP equals FastMCP token access server. Creates an instance of FastMCP with the server identifier token access server. This string parameter serves as a label for the server that will appear in MCP protocol handshakes, helping clients identify the server during communication. The line initializes the MCP Model Context Protocol server with this specific identifier. At MCP, tool. Def personalized greeting, SDR. Greet the user based on their token claims. Defines a function named personalized greeting decorated with @MCP, tool, which registers it as an MCP tool. The function returns a string and includes a docstring indicating it greets users based on their token claims. FastMCP will automatically use the function name as the tool name and the docstring as the tool description, while generating an input schema based on the function's parameters and type annotations.
Token equals getAccessToken.
Calls getAccessToken and assigns the returned authentication token to the variable token. This retrieves the current access token for the authenticated user or service, which can then be used for subsequent authorized operations.
If token is none, return hello guest.
Checks if the token variable is none and returns the string hello guest when this condition is true.
Name equals token, claims get name, user.
Retrieves the value associated with the name key from the token's claims dictionary. If the name key doesn't exist, it defaults to the string user and assigns the result to the variable name. This is a safe dictionary access with a fallback value.
Return hello name.
Returns a formatted string that embeds the value of the name variable within a greeting message. The f-string syntax dynamically inserts the current value of name into the string literal, hello name, producing output like, hello Alice, when name is Alice. This is a simple string interpolation operation that creates a personalized greeting.
At MCP, tool, def user dashboard dict. Return user-specific data based on token.
Defines a function, user dashboard, decorated with @MCP tool, marking it as an MCP tool that returns a dictionary containing user-specific data based on the authentication token. The docstring explicitly states the function's purpose, which FastMCP will use as the tool description when exposing it via the Model Context Protocol.
If token is none, return error, not authenticated.
Checks if the token variable is none and returns an error dictionary with the message, not authenticated, if the condition is true. This is a simple authentication check that immediately terminates the operation and provides feedback when no valid authentication token is present.
Cliented, token cliented.
Assigns the cliented property from the token object to a key named cliented in a dictionary. This extracts the client identifier from the authentication token and includes it in the current data structure being constructed.
Scopes, token scopes.
Assigns the value of token scopes to a key named scopes in what appears to be a dictionary or JSON-like structure. This line is likely part of a data serialization or configuration process where token scopes are being captured for transmission or storage.
Claims, token claims.
Assigns the claims property from the token object to a key named claims in what appears to be a dictionary or JSON structure. This operation copies the authentication claims like user identity, permissions, or metadata from the token into the output structure, making them available for further processing or transmission. FastMCP3's token-based authorization system enables tools to access authentication context through dependency injection, demonstrated here by the getAccessToken utility function. The pattern shows two tools, personalized greeting and user dashboard, that leverage this dependency to customize behavior based on authentication state and token claims. Both tools follow the same structure. They retrieve the token via getAccessToken, handle the unauthenticated case with a fallback response, and then use token properties like claims, cliented, and scopes to tailor their output. This approach provides flexibility for implementing user-specific logic without requiring separate authorization middleware, though it does place the burden of token handling and null checks on each tool implementation. The design choice to make getAccessToken available in tools works well for simple use cases, but could become repetitive in larger applications with many token-dependent tools. The pattern effectively demonstrates how FastMCP tools can access authentication, token data, to make user-specific decisions while handling both authenticated and unauthenticated scenarios gracefully.
The decorator inscribes its name in stone. Yet FastMCP whispers secrets to a ghost.